today, that is third day of the training program on first areas of research and research in the areas of engineering and sciences. And I welcome Dr. Umesh Sharma, who is Associate Professor in the Department of Civil Engineering at University of Technology, who is here today to deliver a talk. There is certain change in the timetable. There is interchange of certain sessions because Dr. Umesh Sharma, he has certain contingency today, so we have to reorganize some of the lectures. That is why you might be in the timetable. You might be seeing that there is a lecture regarding the computer science based research areas, but due to certain contingency, it has been shifted for tomorrow at 11:30 a.m. And the lecture on IPR, intellectual property right, that was going to be held tomorrow at 11:30. That is going to be taken up today afternoon. That is after lunch, post-lunch session. It will be taken by Engineer Amardev. So that is this is the announcement. All other sessions will go on as usual. And so we are fortunate about today that we are going to have a talk from Dr. Umesh Sharma. He has got around 28 years of rich experience in the field of civil engineering, especially in the area of transportation. He has done his PhD also in this particular area. He has got in his name more than 100 research papers in this particular field, and he has guided PhD thesis as well as MTech thesis in the area of civil engineering and especially in the area of transportation. So he is going to highlight the emerging trends of research in civil engineering in today's session now. So I'll request him to guide and engage the session.
Thank you, Paisa. Good morning, everybody. So, first of all, I would like to thank the organizers for giving me this opportunity to interact with you through this media. So, my topic of discussion today will be emerging trends of research in civil engineering. So, civil engineering is one of the oldest branch of engineering, which is growing right from the Stone Age of civilization. Civil engineering is a composite of many branches: structural engineering, environmental engineering, construction engineering and management, transportation engineering, water resources and hydraulics engineering, and geotechnical engineering. Basically, there is a famous saying that civil engineer is a jack of all trades but master of none. That, of course, is justified, and because in every area of engineering, whether it is mechanical engineering, electronics engineering, civil engineer requirement is a must. So, thanks to the branch that civil engineers are so much in demand. As far as the structural engineering is concerned, we all know the importance of the structural engineering. Without the stability of the structure, without the contingency part of the structure, we cannot have the livelihood. We cannot have the, you can say, the civilization going on. Environmental is another issue which is cropping up and which is creating havoc in the minds of the people as well as the planners over there, that everything is being related to the sustainable environmental aspects over there. As far as the construction engineering and the management is concerned, we all know that for every, you can say, execution of the project, we require the construction engineering and the management. Now, construction engineering and the management, they are the separate identities, because construction engineering, the execution of the projects in the field, and the management is the basically the how you have to plan, how you have to execute, and how you have to, you can say, carry forward your project. Now, sometimes what happens, a civil engineer faces some problems in the execution of the project. Once he has got a drawing, and for the execution of that drawing, he requires some, you can say, resources. Now, the management of the resources is a very, you can say, tough task. That is why there's so many of the consultants and other people, they're just depending upon the managers over there so that their projects are going on smoothly. So there, the role of the civil engineer as well as the managers, they come in handy for the top management so that their project is completed within time and within the limited resources. Then the transportation. This is, of course, is the latest trends, because we all are the daily users facing the negativities as well as the positivities of the transportation engineering. Without transportation, one cannot imagine our life, and without transportation, you cannot even imagine that you can survive also. So this, of course, this will be the area which I, of course, will be, you can say, touching upon throughout my discussion. Water resources and the hydraulics, I think now we all are pinching the, you can say, scarcity of the water. Maharashtra is the example which is, you can say, latest, which is coming up in all the newspapers and the media. So management of the waters and transportation of the water, management of the hydraulics, that is itself is a, you can say, dependency of the civil engineer. So civil engineers again for the geotechnical. So geotechnical is nothing but your background of your soil investigations, and every structure has to depend upon the nature of the soil on which the structure is being erected over there. So geotechnical gives us the background of what type of the soil we are going to encounter. Let us say on the building, in the building in which you are sitting over there. In case I don't have the geotechnical knowledge of that particular uh, strata on which this building is standing, I am zero over that one, because a particular load can be taken up by a particular building only if the geotechnical investigations are done. So as far as the geotechnical investigations are done, the investigations have to be thorough, and without the help of the geotechnical engineers, you cannot even design the structure, you cannot create the structure, and you cannot even have all those multi-storied and those skyscrapers and other things at your, you can say, disposal over there. So that means basically the civil engineer is such that in all the areas, the desk on which you are sitting, even that has to be created, that has to be designed as per the, you can say, foundation for that one over there. So civil engineering is coming up like anywhere, in the best possible, you can say, way. So civil engineers serve competently, collaboratively, and ethically as planners, designers, constructors, and operators of society's economic and social engine. So these words, of course, they seem to be very simple, but they have got very very deep meaning. Here, the professional ethics of the civil engineers come into picture. As a planner, in case your planning is okay, only then your project can be executed. Designer. Here again, the true background of the civil engineers will come into picture. In case your design of the building is faulty, you are caught. In case your design of the road is faulty, you are caught. Every common people will just pass the buck on to you that, okay, I have got a very, very poor civil engineer over there. So this is, civil engineers have got a very, very important task as well as the role towards the society, and as a constructor also. Now, of course, everybody will imagine that, okay, after the civil engineering, I am not go to the field and just go for laying the bricks and the cement and other things over there. No, even at the each and every stage, the background of the civil engineering is must. How much cement is to be added? What should be the size of the brick? What should be the depth of the foundation? What should be the size of the reinforcement? What should be the depth of the septic tank? What should be the depth of the dam? What should be the height of the dam? All those things, they come into the, you can say, handy only in case you have got the civil engineering background. And last but not the one, that is operators of the society's economic and the social engine. So society is dependent on you. Mind it, it is the society and the social engine, which of course you'll have to hack. And depending upon your role, you have to just create a society. Type of the society is again why people are praising about the foreign collaborators. Why people are asking the foreign collaborators? Why the Chandigarh was designed by the foreign people over there? Because they appreciated the work which was done by the French people over there. Why we are praising the Japanese roads? Why we are praising the Singapore buildings? Because there is something inbuilt. It is that means the civil engineers have done a marvelous job over there. Civil engineers are protectors of the natural environment and its resources. This is a task which is given to the civil engineers, a very tough task which is there. Now, you have to create the infrastructure, but without disturbing the balance, you cannot create the infrastructure. Now, once you are creating the infrastructure, you have to disturb the balance. Now, that balance has to be disturbed within some parameters. You have to keep the environment in check. You have to keep the resources in check. You cannot keep on digging the earth infinitely. So you'll have to just manage the resources in the best, you can say, possible way over there. So civil engineers, they are the innovators and integrators of ideas and technology across the public, private and academic sectors. This, of course, is the integrators of the ideas. Let us say you are practicing, client is with you, you have to satisfy it according to his needs. You have to get constructed a house. You'll have to see the requirement of the habitats of that house, and only then you'll have to design. So civil engineers as well as the architects, they have got a very, very important role over there. And even in the public buildings also, you'll have to just see that what is the requirement of that public building, what for what purpose this public building is to be constructed. In case it is going to be the office building, in case it is going to be the railways, in case it is going to be the buses, in case it is going to be the malls, you have to see the requirements. You have to see the requirements of all the sections of the society. For example, these days people are feeling the pinch of that we don't have the access to the buildings for the physically handicapped persons. This is what is there. So when the building was designed about 30 years back, nobody had thought of this idea. But now this idea is coming up that, okay, you should have provided the ramps over there. You should have provided the ramps. You should have provided the access to the buildings over there. So that part is basically required over there. So this is what is the innovation which is required. And you have to perceive for the future. It is not so that for the present setup you have to design the building. For the present setup you have to create the infrastructure. To the present, you can say academic requirements, you have to create the things, but you have to see the future also. So this is what is the important task which a civil engineer is required to perform. Then of course, so many calamities, so many disasters, they are happening over there. So civil engineers, you are the managers of risk and uncertainty caused by natural events, accidents, and other threats. Basically, you cannot have the risk-free infrastructure because you have got your hands tied. Take the cases of earthquake. Nobody had imagined that in the Gujarat, so much havoc will be there. In Nepal, so much will happen. Even about 15 days back, so much will happen in Pakistan. Of course, who are the sufferers? It is the common man. And there we cannot blame the civil engineers. But of course, that we can take some safeguards. We can take the safeguards in the sense that, okay, we'll have to see that what are the areas which are prone to the earthquakes. Then we'll have to modify our designs. Now we cannot go for the only bricks. We have to just go for the alternative materials so that they are earthquake proof, so that the lives of the inhabitants are safe, so that they are accident free. So natural contingencies, they have to be taken care of. Similarly, there can be excessive rainfall. So for the excessive rainfall, you'll have to just design, you'll have to just perceive that what can happen. Similarly, for the exclusive summer, when the temperature might be touching 50 degrees, you'll have to see that one also. So you'll have to just manage everything, and uncertainties can be there. So balance is to be required, and that balance comes from the experience. There can be other threats also, maybe because of the storms, maybe because of the wind, maybe because of the other calamities. So you'll have to just, you can say, look towards that one also. Fine. As I have already told you that the civil engineers, they have to make their presence felt over there. So definitely there will be leaders in the discussions and the decision shaping public, environmental, and the infrastructure policy. So from this discussion, we can easily infer that without civil engineering discussion, no projects can be completed. Even if you just want to have the installation of the lift, of course it may be electronic installation, but the background of the civil engineers is required over there. So that is there. Even if you have to install a machine over there, so the foundation of that machine has to be strong enough that the weight of the machine, the vibration which the machine is producing, that is enough over there. So that part, again the requirement of the civil engineers is concerned. Because, and even the railway lines, railway engines, they are designed by the mechanical engineers. Their railway signals are designed by the electronics engineers. But installation of the signals, foundation of the railway lines, and the load which the lines have transferred to the ground, that is again, you can say, taken over by the civil engineers over there. So you'll have to work in tandem with the other branches over there. So from the functional and the beautiful Golden Gate Bridge and the United States, so these are the examples which, of course, they are petting the back of the civil engineers over here. So this is again the marvelous, you can say, civil engineering feature which is there, that is United States, Malaysia, France, and of course then we have got the water supply and the sanitary sewer systems. So civil engineers, they have made the mark around the globe, whether it is undersea construction, whether it is oversea construction, whether it is multiple level construction, whether it is infrastructure construction, whether it is dams and all other things. So civil engineers, they have to be there. These are some of the examples which I'm just putting over there. There are thousands of examples, and of course we can just, you can say, have a pat on our back that our young our brothers or our civil engineer brothers, they have, you can say, created the marvelous things over there. Yes. Civil engineering has increasingly recognized the reality of shrinking resources. Now, this is the problem which civil engineers are facing now. That is, in the sustainable world, you cannot, you can say, utilize a particular material for the, you can say, times to come, for the years, because naturally once you are using the resources continuously, so resources are going to be depleted. So you'll have to go for the alternative. So what is that alternative? So that is what is there. Civil engineering has increasingly recognized the reality of shrinking. So that is again a task which a civil engineer has to do. In the case of the construction of the roads, let us say, you are using aggregates. Now, aggregates, for how long you can use the aggregates? One time you'll be having zero aggregate. So for zero aggregate, you'll have to supplement. So what is that supplementing material? That has to be, you can say, explored by you. The desire for sustainable practices and the design. So that means you'll have to go for the alternative design also. So that thing is to be taken care of, and the need for the social equity in the consumption of the resources. That is a big, you can say, challenge for the civil engineers. It's now highly required to transform themselves from designers and builders to project life cycle sustainers. This, of course, is quite understood that you cannot utilize the resources to the optimum. You'll have to strike a balance. In case my subgrade requires a particular type nature of aggregate, then I'll have to supplement that one. And of course, then for the subsequent layer, I'll have to just see the design. So this is what is required. So civil engineers, basically it is not so that you'll have to execute the road, construction of the road in the field over there. You'll have to alternate design. You may be asked to, that okay, no, this resource is out, you go for the alternative resources. So that is the task which you have to supposed to perform over there. So this is again, you can say, pat on the back. Civil engineers have helped raise global expectations for sustainability and for environmental stewardship by highlighting the use of new environmentally friendly technologies to improve the quality of life in the urban environments. So my dear brothers, so these sentences, they are just giving us a lot of, you can say, task, lot of, you can say, responsibility which we have to perform. So let's gear up for that one, that how it is required over there. So we have to make this word sustainable, and it is not so that usable. Usable is there. For usable, you'll be just using the existing resources, but you'll have to make it as a sustainable also, so that my future is also secure. So these are the stages which are there. Improve designs, routinely incorporate recycling, either by using recycled materials or by making project components recyclable at the end of their useful life. Improved designs routinely incorporate. As I told you, that resources are going to be depleted. Once the resources are going to be depleted, we have to go for the alternative. Now, recycling is another thing. You can reuse the existing material, supplement it with the new material, so at least you can compensate for that one. So that is again a R&D area which is there. New processes, less harmful to the environment, have been implemented, should be explored, and most new construction is based on a green and responsible
Yes,
technology.
sir.
Such broadened responsibility, along with the increasing threat.
ये आवाज उनको इंग्लिश नहीं नहीं उनकी नहीं है
complexity, and rate of change of professional practice all put greater emphasis on research in various areas. So all the areas which have been defined, all the areas which have been categorized, they require the responsibility of the civil engineers, and they have to tackle all the professional practices, and they have to put all their cylinders up so that the research in those areas it is basically leading to the useful activities. Okay, research and development. Now, research. What is research? Means research, explore, and after exploration, go for the development. Means once you have research in area, putting that thing into practice, then the development takes place. So that means bats on the
तो दिख रहा है ना से आपको स्क्रीन
sorry. Research for making environmental considerations as a part of life cycle and cost benefit analysis.
पता नहीं क्यों कनेक्ट
So
नहीं
the
हो
society is giving you a very important task. So for that one, what is required? And they say that okay, civil engineers give us the alternative, and this alternative should be friendly to the users. It should be acceptable. In case your research is not acceptable, and your research is zero, you cannot do anything. In case it is not brought into the market, it is not accepted in the market, it is zero. So that part is to be, you can say, taken care of while we are just executing any research activity. Civil engineering has defined a balanced approach
बंद कर सर
in driving the research agenda, spearheading interdisciplinary, cross-disciplinary, and multidisciplinary collaboration in prioritizing basic research needs on national and global levels. Very deeply. Civil engineering is a jack of all trades but master of none. But he has to collaborate with electronics. He has to collaborate with mechanical. He has to collaborate with production. He has to collaborate with electrical. So that something comes out and it's useful for the society. So interdisciplinary, cross-disciplinary, multidisciplinary approach has to be, you can say, explored over there. Civil engineering quickly moved to the forefront to identify the research agenda to study the application of nanoscience, nanotechnology, and biotechnology. Just see, nanoscience scientists, he may not be ready to accept the civil engineer. Nanotechnology, he will say that okay, mechanical people or electronics people will say no, it is my domain. I won't allow civil engineers to enter into my domain. But no, he is having that misconception that he is all in that one. So basically, we'll have to collaborate with that one. And so civil engineering quickly moved to the forefront to identify the research agenda. Engineers have recognized that nanoscience and nanotechnology products are the new pathways for major technological innovation in the field of the construction. Yes, people have started recognizing that one. Unless and until you know about the background of the materials, how can you identify? How can you identify that okay, this building is going to be heat proof? For heat proof, you'll have to just explore the materials which are available to such an extent that they just, you can say, create the, you can say, heat proof environment over there. Research now focuses on the faster development and deployment of technologies. That, of course, is obvious that we'll have to just go for the fast-track, latest, and the new technologies so that the acceptability is there. In case acceptability is not there, then you cannot go for that. Anyhow, the research during the past 2 decades in the areas of information technology and data management have significantly improved how facilities are designed, engineered, built.
आपकी तो जरिए अदर जरिए कैमरा के नजर में कैमरा को उधर खाता दिख रहा है एक भी पीछे आ जाएगा
What is there that engineers, they are, you can say, facilitated by the softwares. They are facilitated by the data entries. They are facilitated by the computers. They are facilitated by the ITC tools. They are facilitated by the latest technology. That's handy. But the basic research of the civil engineering will remain intact over there, and these are the applied tools, which of course are handy for the software. In addition, it is realized that the technological improvements today may enable applications on the field. That's the gray area. for the civil engineers. Highly integrated planning and construction tools supported by four-dimensional databases have been enabled by significant research investment in expanded computing technology. That, of course, as gradually research is carried out, so you are just, you can say, into that care over there. Real-time monitoring, sensing,
So ये जो दे रहे हैं अभी
data acquisition, storage, and modeling have greatly enhanced the prediction time leading to informed decisions. This is giving us a lot of, you can say, tool with us. Just see the development of the infrastructure, the development of the metro. In the metro, we know that after 1 minute, the metro is reaching my station. How it is possible? That is with the help of the data acquisition. That is with the help of the real-time monitoring. That is with the help of the GIS. That is with the help of the GPS techniques over there. Similarly, we do predict that after this much of the time, this bus is reaching this place. See the app caps. You just get the message that your cab is reaching in 2 minutes. Your cab is over here, this way, that way. Of course, they are using the civil engineering infrastructure, but with the help of what? That is remote sensing, geospatial spatial techniques, GIS, GPS, real-time monitoring. So all those things, they are basically leading us, making us comfortable. So it is nothing, but the application of all those. See the case of the toll plazas. So in that case, what is happening? So it's a vehicle is crossing, right? Automatically, once he is crossing, his weight is also recorded over there. Everything is recorded. Then
देखो सीधे तीसरे मिनट को पढ़ रहे हैं
so smart chip technology
इसका तो नाम नहीं आ रहा है
enhance the materials tracking
लेकिन कॉलेज अच्छा
and reduce the cost. Wearable computing devices facilitate the communication among on-site engineers, workers, and inspectors, and provide access to remote documents and the resources across the global divides. See your WhatsApp. So this you can exchange the data. See other tools, your GPS and other things. You can just find the change which has occurred, and they are just the facilitators for the civil engineers. So instead of going to the field, carrying your theodolite and all other things, slogging for the whole of the day, and just getting, let us say, 20, 30, 40 levels over there, now you can get whole of the area in single sheet of the paper with the help of your instruments, with the help of your GIS and the GPS techniques over there, and by sitting in your cold environment. Application of computers and communication technology for intelligent transport systems need further study for its proper implementation. That is the research which requires over there. That's, of course, everybody says that, okay, we can borrow the technology from the abroad. No, that is not possible, because borrowing the technology as far as the transportation is concerned is, you can say, may not be suitable for us, because the nature of traffic, the nature of transportation systems, the nature of demand which is there in the Indian conditions is entirely different than the abroad over there. So that, and even the social and the demographic structure is entirely different over there. Of course, we can just get some idea over there, but well, because the heterogeneity of the vehicles and the homogeneity of the vehicles, they mismatch a lot over there. So that has to be taken care of. A variety of advanced sensing, computing, and communications technologies handle tasks that range from collecting tolls to controlling traffic signals, and they are integrated into coordinated systems that manage traffic flow. The full impact of computers in our profession has not been realized yet. Far more is still to come as computing power and optical and wireless networks continue relentlessly to double in power every 2 years. That, of course, is there. Still we are lagging behind that one. Still we are not complete. So daily we are just getting more and more, you can say, inputs, and then we are just, you can say, we are just applying those things over there. Similarly, the innovations in information and telecommunications, such as satellite GPS for precise site measurement and control in real time, are reducing the cost of the design and construction. You can now design 20-story building within 2 hours. And earlier on, we used to design a single-story building in 1 month. See the difference which is there. So it is not so that the civil engineers have vanished from the scene. Civil engineers have been, you can say, facilitated by the other branches, by the other tools, so that we are able to, you can say, serve with the society, and we are able to see the, you can say, meteorological predictions. These are possible only once we are having those type of you can say activities, and people are dependent upon those activities. So while civil engineers play the central role in planning and building the necessary infrastructure for the growing population, it's unlikely that yesterday's technologies will suffice for tomorrow's challenges. Nobody can predict that the earthquake is going to be of this magnitude. Nobody can predict that this section is going to be sufficient for the time to come because my population is rising, my demands are rising, attitude of the people is changing, demography is changing, so everything is changing. So civil engineers, we have to change. We have to, you can say, plan the things in such a way that we are just, you can say, my present technology is not sufficient. So just to explore the technology, I'll have to think in what way, so that after some time people don't discard me. So we'll have to be, you can say, conversant with the latest one over there. So yesterday's technologies cannot be sufficient for the tomorrow's challenges. So let's see what we can do, what a civil engineer can do. Now, this is the latest issue which is coming up, that is transportation issue. This is one issue which, of course, well, I'll make it very handy. Today, in a particular city, we are having 5 lakhs vehicles. After 2 years, I'm having 7 lakhs vehicles. After 10 years, I'm having 15 lakh vehicles. So that means today people are garlanding civil engineer. Okay, very nice roads. I was able to reach from this place to this place in 5 minutes. But after 2 years, the same very people will be saying, yeah, what a civil engineer he has done. A lot of congestion is there. And after 10 years, you'll be just, you can say, going underground because people will be after your life. And what you have done a faulty design. You were not prepared for the future. So we civil engineers, we have to be prepared for the future. And that is how it is possible. Projection of the present trend of the vehicle usage reveals a rather ugly and unsustainable situation, both in terms of traffic congestion, air pollution, and noise pollution. So these are the challenges which are coming up as far as this transportation area is concerned. So these challenges, they have to be, you can say, taken care of. And how they have to be taken care of? The effects of the population growth. These are the causes: increasing transportation congestion, decaying infrastructure, shrinking waste management options, environmental deterioration, destruction from disasters, and the effect of global warming represent a significant problem to mankind which must be mitigated by the civil engineers. So just responsibility which a civil engineer is going to have. There's a need to develop solutions to these complex problems using innovative approaches involving the most effective technological and management techniques. It is not so that the civil engineer himself can be innovative. He has to take the help of the other branches also, which of course, how is it possible? Alone, a transportation engineer cannot solve the problem. He has to take the help of the other people over there. Let's come to the basic. Why my roads are congested so badly? Why is my road network poorly managed? How to make our roads smarter? Now, these days we are talking about the smart cities. How can we make the road smarter? It is not so that we can increase the width of the road and then okay, we'll say that okay, Mr. X, you can move freely, you are smart enough. No, that is not the responsibility which a civil engineer is supposed to undertake. Why roads are congested so badly? Why road network is poorly managed? So all these things are linked up. So what we have to do? Because this is a chronic problem which is, you can say, mind-boggling for the civil engineers. Everybody is blaming the civil engineer. It is not only the mechanical engineers. So mechanical engineers, they are designing the buses. They are designing the buses environmental friendly. Electronics people, they are giving the electronic buses. They are giving us the electronic cars. They are giving the electronic trains, bullet trains, all those things. But infrastructure we have to create, keeping in view their demands over there. So this is the task which we are supposed to perform over there. So this is what is there. Just imagine what is happening. Our population is increasing, and just see the prediction. As I told you that okay, in the present we cannot live, for the future we have to live. So what is going to happen in 2050? See what is happening in Brazil, what is happening, Russia, what is happening, India, how we are prepared over there, China, and all those things. So what it is going to happen? it is again going to boomerang on the civil engineers. Civil engineers have to be awakened enough that okay, no, this bombshell is going to come, so we have to be prepared for that one. So in what way we can tackle that one? Let's see. Now, my population is increasing. So it's not so that all the increased population will be moving on foot. So they'll be buying the vehicles because that is a necessity. And for necessity, so in every part of the world will be having the vehicle growing. So once my vehicles are growing faster than my income, so that means I'll have to create the infrastructure. And once I'm asked to create the infrastructure, I'll have to explore. I have to go for the research. So what type of the activity I'm supposed to find it out? Let's see. So ultimately, it is leading to what? Increasing the population, increasing the vehicles. Ultimately, it is creating these problems. So here also, people are after civil engineers. It is not the fault of the users also that they are just, you can say, using the roads at their own street will and other things. But the problem is really reflected into this one. It is not so that we are not having the adequate space. This one also. Once you are parking the car, you'll have to wait for another person over there, and so that he can just come and just wait. Yeah, let Mr. A go, and then only I'll be coming. This is another situation. While moving, also everybody wants a space. So my roads are packed over there. This is another story. So ultimately, leading to what? Just have a look at it. I asked him, Mr. Singh, he says that he's getting prepared for the future. That means one day is going to come that I'll have to discard my vehicles, and again I'll have to come to those old civilizations that okay, I'll be using my animal drawn vehicles over there, so that they don't require parking. They don't require any infrastructure. So that means what the civil engineers they have done it for the last 400, 500 years, that is going to end ultimately into a zero. So civil engineers are not, you can say, born for this thing. So ultimately, we'll have to explore that what we can do for the future to come. Okay. Again, let us see why this traffic congestion is happening. Population is increasing, income is increasing, prices, car prices, because that is another sector which is coming up, which is there. Then fastest growing car market world, and the world is, you can say, developing. Then increasing car ownership, population spread, and under-resourced network, which is there. Now, under-resourced network is that means civil engineers are being blamed indirectly over here, which is there. So that again will have to, then ultimately it is leading to what? Urban traffic congestion. So again, civil engineers, they didn't work properly, that is why the congestion is there. So let's see what are the challenges before us. Okay, we have been talking about the congestion, we have been talking about the inefficiency and other things over there. But you know what is the price which we are paying for the congestion? Because in case we are able to tackle the congestion, what we'll be doing will be serving the humanity, will be serving the society. So these are the, you can say, this is the cost which society is paying. First is time loss, very precious loss, fuel loss. You are made to stand at the intersection, fuel loss is there. And increasing the operating cost, that's also very taxing. Increase in accidental cost, that is also there. Loss in the revenue generation. Then of course the other activities are also there. So all those things, basically what can be done? Civil engineers, we can reduce it by the better management. So better management is only possible in case we just explore the areas. That what are the reasons for exploring? We'll have to see that what are the reasons, what can be done, and what are the predictions, and in what way it can be, you can say, put into operation. Only then we can, you can say, work upon. Just have a thought to this one. That is time loss. Everybody is after the time. Everybody has got a very precious time. Whether he's in the village, whether he's in the city, or whether he's traveling over there. So that part is to be taken care of. So this is a tremendous, you can say, exercise which is required to be done by the civil engineers. That okay, in case we are able to time manage the things over there onto the transportation system, will be you can say serving the sections of the society. Now let us understand what are the time factors. You are traveling on a road, or you want to reach your destination. From your home, you'll just reach the bus stop. That is your access time. Then you'll be waiting for the time, waiting for the bus. Then you are getting a bus and traveling into the bus. Then in case you have to get another bus, you'll be changing the bus. This is what a common person is doing while using a transportation system. Whatever, whether it is a metro, whether it is your bus, whether it is your auto, whether it is your rickshaw, all these four stages he's just undergoing over there. Beyond that, no activity is taking place. Right? Now, in this case, what a civil engineer can do? Now we have to tackle the congestion. Now, in order to tackle the congestion, we have to discourage the people from using the road so that my road space is available. So that is called my management. Goals of traffic management are to make the productive use of the road capacity and the maximum safety. This has got a very deep meaning. You have designed a road, let us say 2-lane road or the 4-lane road. 4-lane road, at the most, it can accommodate about 5,000 PCUs of the vehicles. Fine. In case it is exceeding 6,000, 7,000, jam will take place. Let us say I am making the road where the safety is not there. That is, again, the blame is on me. So that means I'll have to take some measures. It includes some measures to manage the supply of the road space, improve the road capacity, or quality, or the safety. But I cannot improve the road capacity by simply widening the road. I cannot do it because my space is limited. In case I have to develop a new city, I am at a liberty. But even then, I cannot go beyond a particular limit over there. There are some specifications by the Indian Road Congress. So in that case also, improving the road capacity is fine, agreed, but there is some limitation. Similarly, quality. That again is dependent upon the civil engineer. Safety, signalization, zebra crossings, slip roads, all those things, they have to be provided. But they cannot tackle your congestion. The congestion has to be tackled only in case you are just having R&D areas. You are just exploring the possibility that what is, you can say, going on over there and what is required over there. That part is to be, you can say, seen. So you have to seek to adjust, adapt, manage, and improve the transport system to meet the specified objectives. Presently, let us say my objective is just to tackle the congestion. My objective is to just manage the traffic. My objective is to just to make the maximum use of the road capacity and the maximum safety over there. So these are the tasks which I am supposed to manage. These are the tasks which I have to prepare for the future. These are the tasks for which I have to study my inventory. I have to study that what is happening over there. So objectives of the traffic management for my civil engineers, just to facilitate and enable the travel of people with ease, efficiency, and safety. Optimize the system capacity and the maximize the safety, which of course is there. And moreover, mind it, in case I just, you can say, allow a particular vehicle to travel, let us say at 200 km per hour, it is not so that the civil engineer has done a marvelous job. Not at all. You'll have to just take care of all the sections of the society. You have to take care of all the, even the slow pedestrian also and the fast moving vehicle also. So that part is to be saved. That means maximize safety. You have to provide the safe system to my pedestrian also, to my rickshaw also, to my trolley also, to my old people also. So I have to just manage the traffic because they are also part of my traffic. Traffic is categorized into two categories. One is non-motorized traffic and another is motorized traffic. So safety is priority for both. It is not so that a Muslim person is driving and he is just crushing my pedestrians. That is the biggest, you can say, drawback of that particular road system. And the blame is on the civil engineers. That is the faulty design. Provide priority for the public transport or the mass transport system. That is there. Because without this system, you cannot sustain any traffic management system over there. This, of course, that so many systems have started prevailing over there, but you'll have to take care of this thing also. That will again depend that how much quantum of the, you can say, passengers are for using this mass transportation or the bus system over there. Facilitate the convenient and the safe movement of the pedestrians and the non-motorized traffic. Okay, we have talked a lot about the transportation. We have talked a lot about the vehicles. We have talked a lot about the pedestrians and other people over there. But there are some effects also about maybe the horror, maybe the pollution, maybe the other things over there. So this thing again has to be there. Okay, I am providing the capacity for all the vehicles to move. I am providing the facilities for all the vehicles to move. But you know what the vehicles are doing to me? They are just, you can say, creating a lot of pollution to me. And this flow chart is showing that pathways from the pollutant sources to the toxic effects. And ultimately, whatever pollution is being generated, it is just going into the bodies of the users over there, bodies of the human beings over there. And ultimately, what is happening? Their health is being affected over there. There are two types of emissions as far as the pollutants are concerned. One is the fuel engine characteristics emission controls, then the mobile source emissions, then of course from the atmospheric pollutants. Then all these are just giving the negative exposure to the users, and all these they are just going through the, you can say, inside of the body of the users and just creating the toxicity and creating the negative impact on them. So once I have just, you can say, stressed upon the pollutants which are being generated because of the transportation issues. So let me understand what a pollution is. So it's nothing but it is an introduction by humans deliberately or inadvertently of substances or energy, heat, radiation, noise into the environment, resulting in a deleterious effect. Whereas contamination is the presence of elevated concentrations of substances in the environment, food, etc., which are not necessarily being harmful or in nuisance. So this is the pollution as a general. But as a transportation, what type of the pollution which we are just, you can say, facing? The pollution can be primary, having effect immediately on release to the environment, or secondary, the product of interaction after release with the moisture, other pollutants, sunlight, etc. Pollution may be local, regional, global, or the transboundary. The effects may be direct, indirect, or the cumulative, felt intermittently or constantly, immediate or after a delay, affecting the atmosphere, water bodies, oceans, groundwater, soil, or be restricted to certain organisms, produce or the localities. Basically, any type of pollution is very much harmful to the human beings. The effect of pollution may be short term or the long term, pose a hazard or a nuisance, be toxic or non-toxic, take the form of a chemical, biological, radiation, heat, light, noise, dust or the other problem over there. Now I'll be dealing specifically with the, you can say, negative impacts of the road transport on the social and the economical environments in terms of congestion, air pollution, noise pollution, annoyance, accidents, and other things over there. So basically, what is there? Till now, we can easily conclude that okay, fine, transportation is a problem, not as far as congestion is there. It is again affecting the human beings also as far as their health effects are concerned, whether it is in the form of air pollution, or whether it is in the form of the noise pollution, or whether it is in the form of the accidents and other things over there. Such environmental effects lead to poor visibility, high accident risk, noise pollution, air pollution, diminished aesthetics, impairment of ecologically sensitive area, and high costs in using transportation system. Imagine a vehicle is constantly blowing the horns near the hospital. Just imagine the plight of the patients. A vehicle is constantly putting the horns into near a hall where the examination is going on. Just imagine what is going to happen. So, what is what is the after effect? So everybody is going to curse. So that part is to be, you can say, seen over there, that how it can be, you can say, utilized. So air pollution is one of the, you can say, uh, outcome is basically the presence of the foreign substances in the air in excessive concentration, which adversely affects the well-being of the individual or causes damage to the property. According to World Health Organization, air pollution is defined as substances put into air by the activity of mankind into concentration sufficient to cause harmful effect to his health, vegetables, property, or to interfere with the enjoyment of his property. This is a very general, you can say, definition which WHO has given us. But as far as the civil engineers are concerned, will be just, you can say, deliberating from the context of the transportation air pollution and how it can be, you can say, utilized. Indian Standard Institute defines air pollution as air pollution is the presence of ambient atmosphere of substances, generally resulting from the activity of man in sufficient concentration, present for a sufficient time and under circumstances which interfere significantly with the comfort, health, or welfare of the persons or with the full use of or enjoyment of the property. Now, being civil engineers, we experience the fog. Now, why fog is there? Why photochemical smog is there? It is not so that suddenly the atmospheric changes have taken place. It is because of the creation of the mankind, because of the pollution it has come up. Because ultimately, whatever is the pollution, every pollution is not going into the bodies of the human being. They are suspended in the atmosphere also. So ultimately, they are just creating a blanket over there. So higher emissions from the road transport have increased concentration of harmful air pollutants to levels which frequently exceed public health guidelines and the standards. Motor vehicle exhaust is a complex mixture. Its composition depending on the fuel type and operating condition of the engine and the use of any pollution control device. Pollutants and their derivatives can cause adverse health effects by interacting with and impairing molecules crucial to the biochemical or physiological processes of human body. Basically, this is a background of all the pollutants which are there. Just see, this is what is there. Ultimately, these are the toxic gases which are being inhaled by the persons who are standing nearby or the adjacent, you can say, people who are just using that one. So these are the sources of air pollutants. One is the point source, which are the stationary sources. For example, chimneys of the industries, chimneys of the power plants, then municipal, you can say, biodegraders. Area resources, these are the small stationary sources and the mobile sources with the indefinite routes such as residential heating, commercial and institutional heating, open burning, city traffic, etc. Then the mobile sources, line sources, these are the highways, railway tracks, navigation routes, then area sources, airports, railway stations, and airports. Just imagine people who are living near the bus stand, people who are living near the railway stations, people who are living near the navigation routes. See the amount of noise, see the amount of air pollution which they are going to face over there. So basically, air pollutants are classified and according to the origin. So primary air pollutants are those which are emitted directly to the atmosphere and found there in the form in which they are emitted. For example, carbon monoxide, SOx, NOx, hydrocarbons, radioactive compounds, particles of metal, pollen, bacteria, etc. The five main primary air pollutants are CO, SOx, NOx, SC, and the particulates, which contribute more than 90% of the global air pollution over there. So these, of course, out of these, basically CO and the SPM, they are the very, very, you can say, negative impact over there. Secondary air pollutants are those which are produced in the air by the interaction among two or more primary air pollutants or by reaction with normal atmospheric constituents with or without photoactivation. For example, ozone, peroxyacetyl nitrate, formaldehyde, formation of acidness, smog induced, coal induced, and the photochemical smog, etc. These are the secondary air pollutants which are there because they just combine with the other agencies and then they create the negative impact. And according to the chemical composition, on the basis of the chemical composition, air pollutants can be divided as organic and inorganic air pollutants. Organic compounds contain carbon and hydrogen, and many also contain certain elements such as oxygen, nitrogen, sulfur, and phosphorus. Examples of organic air pollutants are hydrocarbons, aldehydes, ketones, carboxylic acids, organic sulfur compounds, etc. Being civil engineers, we are not concerned about these chemical, you can say, compositions, but of course, we'll have to put our foot down so that we have to handle it from the civil engineering point of view. So these are other compounds which are there: CO, CO2, SOx, NOx, according to the state of the matter. This is basically the chemistry guided, you can say, matter. Particulate air pollutions include finely divided solids and the liquids, dust, smoke, and other things. Then this is gaseous air pollutants like benzene, methane, butane, aldehydes, as well as the inorganic gases like SOx, CO, NH3, H2S, NOx, etc. Effects of air pollution on the human health. This, of course, we already have the background of our earlier, you can say, classes. For example, the air we breathe has not only life-sustaining properties, but also life-damaging properties. An average man breathes 20,000, 22,000 times a day and takes on 16 kg of air each day. The impurities in the inhaled air can affect human health in a number of ways, depending on the nature and the concentration of pollutants, duration of exposure, and each group of the receptor. Just see the danger which we are there. The various effects are, for example, eye irritation caused by NOx, ozone, fan, and the smog. Nose and the throat irritation caused by the SO2, NOx, insecticides. Gaseous pollutants, SO2, NO2, hydrocarbons, and other nuisances. Irritation of the respiratory tract by NOx, increase in mortality and the morbidity rate. And the various health effects are like eye irritation, nose, and other things. High concentration of SPM, photochemical smog, can aggravate chronic diseases like bronchitis and asthma. Carbon monoxide, which is 200 times more reactive than, because it combines with oxygen in our blood and it creates a very negative impact. Hydrogen fluoride can cause fluorosis and the teeth damage. Then air pollutants such as polycyclic organic compounds, aliphatic hydrocarbons can cause cancer. Dust particles can cause, even the dust which is being by brooming by your street sweeper, it again creates that problem also. So danger is there. Heavy metals like lead may enter the body through the lungs and can cause poisoning. Its high concentration can damage the liver and the kidney and can cause abnormality, fertility, and pregnancy and the mental development. Then exposure to radioactive isotopes like iodine. This is again, you can say, background of medical, you can say, people as well as the chemistry people over there. But there are some standards which are given by the Environmental Pollution Agency. Standards are there. So these are the limits which have been set for carbon monoxide. Average is there, 1 hour average is there. 9 ppm means 9 parts per million. So 1 hour average, 35 parts per million. Nitrogen oxide, ozone, lead. Because why I'm just stressing upon this one, because they are the pollutants which are basically, their primary source is the vehicles which are there. So then how we can, you can say, handle these ones? It is the prime duty of the civil engineer that they have to explore. That okay, we have to minimize the pollution over there and we have to maximize the efficiency of the transportation at that stage. These are the Indian national standards: sulfur dioxide, then RSPM, lead, carbon monoxide, and other things. And they, of course, have categorized into 3 areas. One is industrial area, residential area, and the sensitive area. Sensitive areas like your hospitals, schools, and your ecologically sensitive area. Industrial area, see the quantum of the, you can say, values which are there. In industrial area for sulfur dioxide, it is 80 is the average, but in residential area it is 60, and for sensitive it is 50. So just see the, you can say, sensitivity which is given to a particular area which has to be there. And another pollution is by noise pollution. This, of course, whereas the air pollution can affect from the local level to global level, traffic noise is a nuisance in the urban areas and in towns that suffer from a lot of through traffic. And at locations around the transport terminals. As I have already told you, that a person who is just having his residence near the railway station, near the bus stop or stand or near the metro station, just imagine the plight of his, you can say, surviving. So effects of noise can be broadly classified into auditory effects. Addressing the change caused to hearing. All these are causing the, you can say, damage to our hearing. In most of the cases, hearing loss is caused by gradual shifting of the threshold of the hearing. Noise-induced temporary threshold level, nets related to temporary displacement of heavy threshold level, and when the frequency of nets is more, it becomes more chronic and develops noise-induced permanent threshold shift. I hope the name suggests. In the beginning, you will require a person to speak at a louder voice. Only then you will be able to listen it. And ultimately, the stage will be there that you won't be able to listen to that chap over there. So this is nits and the nips. They are the two terms which are, you can say, having those marks. Then non-auditory effects relating to interference with speech communication, sleep work tasks, and the annoyance. Once you are sleeping, you'll be suddenly waking up because of the noise and other things. Now, this sound level meter is a very handy instrument for our civil engineers. Now, with this, we can just measure the noise level of a particular area and just see whether they are exceeding a particular limit or not. Because standards are already defined, EPA standards are there. We can just measure and just, you can say, just compare it for whole of the day and just find out that what is the average level of the sound which is, you can say, coming up. So it is just an instrument. It's a commonly very common instrument. It can be held in the hand like a mobile is there, and they are commonly used for the quantification of different kinds of noise, especially for industrial, environmental, and aircraft noise. However, the reading from a sound level meter does not correlate well to human perceived loudness, which is better measured by loudness meter in addition to that one. And these are the standards, FHWA noise standards. This is Federal of Highway Association. They are basically dealing with this highway noise, transportation noise only. So land use category E, B, C, and D over there. Land use means use to which a land is put. Then the design noise level L10 is the parameter which is decibels. Description of the land use category for parks. Whenever it is a park or the open spaces or the quietness, then it is taken as a land use category A. Part B is residential areas, hotels, schools, churches, libraries. They are under category B. C is the developed areas, and D is the residential areas of the hotels or the, say, libraries. Now, ambient standard. These were the international standards, but India, they have given their own standards for silent zone. They have given as a 50 LEQ, and during the daytime, during the night it is 40. And for residential, during the day it is 50, 45. 65 in the commercial for day, and during the night it is, so night they are less, and day it is more, because there you can say natural barriers are there because of the movement of the traffic is going on. Now, areas up to 100 meters around certain premises like hospitals, educational institutions, and courts may be declared as a silent zone. This is the distinction which is there. And night time is considered from 9 to 6 there. And daytime is from 6 to 9. These are the standards which India has set up. That is CPCB, Central Pollution Control Board. They have set up the standards from this one. So we have to follow these standards. Okay. Now, basically, in case we have to just use the negative, you can say, pollution for the betterment of the transportation, then we can do some research over that one. So let us say it can be a blessing in disguise for the transport engineers. In case my transportation vehicles are giving me the pollution problem, I can handle that one and use it in a positive way also. For example, any study related to environmental pollution should be a joint concern of so and so. The study of the has different, you can say, dimensions. Let us say I assess the air and the noise quality by field measurements and compare them with the standards. I have identified the locations. I'll find it out air pollution as well as the noise pollution over there. Then I'll start preparing a model, air noise pollution model to determine the pollutant concentration. Fine, that is also agreed. I can prepare a model, get a data, prepare the model. And then how I can utilize that particular model. Now, to prepare a model, to get a data, I have to carry out certain steps. What are those steps? I have to carry out the traffic statistic studies. That what is happening on my road, what is happening during the time, during the daytime, during the night time, like that. So what is happening, again I have to see, and then I have to, you can say, get very authenticated data over there, because my aim is to prepare a model, and that model will be just, you can say, will be utilized for the management of the traffic. This is my R&D, this is my research, which I'm going to start over there. So for the research, we require parameters. So this is one of the important parameters. Now traffic characteristic means what? It requires volume, it requires speed, right? It requires inventory of the road, it requires direction of the traffic, it requires time of the traffic, it requires season of the traffic, it requires whether it is an annual variation, daily variation, seasonal variation, and it requires whether it is on a working day or a non-working day. So like that. Then similarly, second, noise pollution due to traffic at different locations in the city. Just see, you might have seen them in the previous slides that we have got different areas: residential, commercial, industrial, silence. So definitely I'll have to identify those areas. And then I'll have to find out the noise pollution due to traffic at the different locations. So my locations are given by CPCB. I have to measure the data and see what is happening. Similarly, ambient air quality in correlation to traffic. So that means, in case I am able to lay my hands onto this one, then what I can do, then based upon the data collected, I can prepare a specific model for the air and the noise pollution, fine, with the data for whole of the year. It is not for the season, because that model can vary depending on the season. So whole year data is required for this one, and whole 7 days, 7 into 365 days data is required, and I'll have to develop a model. Then these models should be validated. Your model is useless unless and until it is validated. Once you validate the model, only then you'll be able to use it. Otherwise, model, I 10 बार एक दिन पे 10 बना दूँ. I'll prepare 10 models, but what for? Unless and until somebody can use it, which will provide the necessary direction for the future and will also facilitate recommendations and guidelines for the urban transportation planning. So this is what is the, you can say, concept of research. That okay, parameters are there. You have to apply these, and based upon those parameters, prepare a model and then validate the model and then give your recommendation. Only then you'll be a successful researcher over there. Otherwise, collecting the data, anybody can collect. No background of civil engineering is required. Even getting the conclusion from the data, any statistical person can do it. But preparing the model, keeping in view the background of your civil engineering, is a must over there. This is what is the, you can say, research for the civil engineers. So this is, I'll give you a case study. I'll give you a case study over here. We carried out a study in one of the areas, and we applied exactly the same thing over here. So what we did, we just, you can say, divided the area into different sites. What? Identification of the sampling site. First of all, I had a recce of the area. Then identified some sites so that, okay, I'll just identify, for example, sensitive area, residential area, commercial area, then this market areas. I identified, and I said that, okay, these are my areas, and I'll be taking up the data from these particular areas. Now, because identification of sampling site is a very, very important task. Reason being, in case any of the important site is left by you, and it is having a bearing on your model, that means your model is faulty. This model cannot be applied. This model cannot be utilized. So that means your research is zero. So the research is nothing, but you'll just keep on knowing that what are the parameters which are required over there. So identification of the sites or identification of the parameter itself is a, you can say, task which of course requires a lot of, you can say, uh, uh, study over there. Then the traffic studies. What type of studies I require? Let us say I require two types of the studies only, but I'll have to just see the literature that okay, whether these are sufficient or not. In case these are not sufficient, then what else can be there? Again, I'll have to see. Then maybe that in case this parameter is not available for that particular site, I'll have to change the site also. So that means first and the second they are correlated over there. So once the first and the second are matching over there, then I'll have to go to the third one. Because third and the fourth, they are the nothing, but they are the, you can say, outcomes of that one. Because first and the second, they are giving me the sites methodology, and the third and the fourth, they are giving me the, you can say, giving me the confidence. Okay, fine. I'm just working on these things, and then these are my, you can say, this is my thrust area, which is going to be there, right? So what happened? Then the experimental protocol is decided. In the traffic statistics, let us say traffic volume, I have identified, let us say, two things, traffic volume and the speed. But there are various methods of traffic volume. There are various methods of the speed. So in that case, what I have to do, whether I have to go for the manual method or whether I have to go for the mechanical method, that again the decision which I have to take. Because sometimes the traditional methods are more useful than the latest methods. So that thing is to be kept in mind. So while doing the research, one has to be flexible enough. One has to have the acceptability that okay, fine. नहीं, अगर उसने ऐसा किया था, I cannot do it or I won't do it. No, this is not so. Because you have to explore. Sometimes 200 years back method may be useful still for your work. That again depends on what type of parameter you are using. Similarly for the noise, that is the noise level. So that means what type of instrument I require, I have to decide. So that is the method which is there. Then what type of analysis I am going to expect, like L10, L50, L90, and LEQs. These are the parameters. L10 is the parameter which gives that 10% of the, you can say, noise is exceeded by that value. L50 means 50% of noise is exceeded by this value. 90 means this one, and LEQ is a formula which is used to find out from this one. The meter will be giving us L10, L50, and L10, which is a noise level meter. Then the air pollution, that is the CO. CO monitor is again, which of course there are so many CO monitors. So one type has to be decided because you have to be sure that I will be using, because once you are onto the site and say that you are which type of that is a poor, you can say, research. So before going into the field, you'll have to just do a homework in such a way that everything is crystal clear in your mind over there, and all those parameters. So this chart is very much handy. This chart will be handy till you compile your research, till you give your recommendations over there, because then you can do the reverse engineering. From the reverse engineering, what you can do that, okay, I had planned this one, that was my objective. Whether I am able to achieve my objective or not, this is what is there. Then let us say I identified these sites, residential, silence, commercial, and those. So sites are identified. And on the sites, traffic flow was found out. In the traffic flow, some data was found out. Then chart was prepared. Now you just see, this is one of the examples which is being quoted over there, that during whole of the time from 8 o'clock to, let us say, 6 o'clock, this is one part of the chart which is there, because it's not possible to show all the charts. 8 o'clock to 6 o'clock, let us say, 10-hour chart, and I'm just seeing the variation of the traffic which is there. Means from 8 to 9, I am having, say, a particular value. From 9 to 10, I am having a particular value. Then it is decreasing, then increasing, and all those things. So that means I am able to just know about the quantum of the traffic which is there on a particular location, in a particular direction, on a particular day. Just see, it is written now, sector 22, that is location, direction towards 23, day, Monday. Time is at the bottom, and PCU is another parameter. which is nothing because we'll be recording your traffic in terms of the how many cycles, how many scooters, how many. So basically, all that traffic has to be converted into a single unit. Only then you'll be able to compile the data. So that there's a conversion factor which is coming from the Indian Road Congress. There's a code IRC 106 over there. From the code, you can convert it into the PCUs, and then you can get this type of the data. Then after this, you can find out the speed and the Sunday, Monday, Tuesday, and all that speed is there. And this is again for direction as well as the day. It's not moving on that side. Okay, now it's. So this is, then I have found out the pollutants. Found out the pollutants on the off days as well as the on days, and then just see the type of the pollutants and the, you can say, timings of the pollutants which are there. For finding the pollutants, the Indian Standard Institute, they have given the codes for the carbon monoxide. We utilize equipment which is called as a high volume sampler. It is installed on the site, and then we just find out the different, you can say, pollutants. NOx, these are the gaseous, you can say, pollutants which are there. And depending upon the values, we can just, you can say, interpret in the form of the bar charts over there. Now you just see, let us say from 9 to 10, in case my traffic is also high, very much high, then I can easily correlate that, okay, this pollutant is because of my traffic over there. Because simultaneously I am doing that activity also, which is there. So that means teams have to be made. One team is for the noise, one team is for the air pollutant, one team is for the traffic data over there. So all those three parameters are being measured simultaneously over there, and at the end of the day, you're just, you can say, compiling and just finding it out over there. Now, after I have collected the data, huge data is there. Now my job is to prepare the comprehensive model. Ultimately, this was my objective. That I have to collect the data and I have to prepare a model. So that model is to be prepared, keeping in view the air pollutant as well as the noise pollutant as a separate, and vis-a-vis traffic characteristics. What type of the model I can develop? Let us say. Let us say this is my model for the noise. LEQ is 37 point something, 4.2 VN, so and so, and in case of the noise pollutant, the model correlating this, LEQ is noise equivalent, VN is the volume of traffic on the near side of the road, SN is speed of the traffic on the near side of the road, VF is volume of the traffic on the near side of, you just see. What does this signify? 4.269 log to the VN. That means 4.269 is a very important, you can say, figure for this, because VN is nothing but your volume of the traffic on the near side of the road. Means it's you can say nuisance value is more than 0.254 VF. That is on the far side of the road. So from this model, basically you can have a idea that what type of the activity which is there. Then there are softwares, that is SPSS, which is there, from which you can just find out the p-value also. And in case my model is okay, then p-value should be less than 0.0001. And in case it is not that one, that means my model is missing some of the parameters and it requires a revision over there. Similarly for the air pollution also, right? Now you just see the models which is there. TB is the traffic in passenger car units, right? CA is concentrated carbon monoxide, N is the NOx, and S is the so and so. That means my traffic volume is having dependency on the pollution, C, N, and other things. And similarly, in the previous slide, we had seen the noise over there. Now validation. Now I have prepared a comprehensive model. Then I have to validate my model. Now for validating the model, I'll be collecting another data and then finding out the predictions. This is one of the same process was done for the new site, for the validation site, and then for that I have prepared the same thing over there. And for that, what I'm going to do, the same traffic speed, traffic volume is the same, noise level is also the same. Then of course now here is the comparison. This is the comparison. Now column number 1, serial number, LEQ is the observed, LEQ is the predicted. Just see the validation. LEQ observed means from the new site. This is the from which the validation is going on, and predicted from my model. Just see the difference. Very less difference is there. So this is what is, you can say, the hallmark of this basically research, that unless and until you do the validation, your model is not usable over there. This is as far as the noise is concerned. Now, in case I just go for, this is again the comparison in the form of the bar charts. Then this is air pollution. Similarly for the air pollution also, the data was found out, and at the different timings for the non-working and the working day, the data was found out, and this was the comparison. Traffic was observed and predicted, and this is what has happened. So this shows that my model is fully in agree with that one, and just these are the bar charts, which just supports that okay, that was the objective which was to be carried on. So from this, what I conclude that okay, my model can be utilized, and my model can be used to, you can say, manage the traffic, keeping in view in case I got my pollution parameters with me, I can, you can say, divert the traffic, keeping in view the pollution parameters. So basically for the traffic management, I can just, you can utilize that one. For example, the noise models can be used to find the noise levels at a particular location if the values of traffic volume and speed on the near and the far side of the observer is not fine. To combat the noise problem due to traffic, the traffic management measures can be taken to bring traffic volume and speed under control. That is very important one, very handy for the civil engineers. When air pollutant concentrations is known by carrying out the air pollution studies, that the traffic volume can be known and the vice versa. Similarly, traffic management measures can be adopted in the problematic areas. The model correlating, because sometimes you don't have any time to go, you don't have any expertise to find out the traffic characteristics, then you can just go for the measurement of the environmental parameters. So that can be handy for you. The model correlating the air and the noise pollutants to the traffic characteristics can be used in traffic planning and the management from the environmental point of view. The noise models. So this is all I wanted to share with you. Thank you very much.